Okay, MCQ related chemistry. Chemical equilibrium is a state in which chemical equilibrium is a state which forward and backward reaction occur at the same time. Chemical equilibrium is dynamic. At equilibrium, the concentration of reactants and products may or may not be equal. At equilibrium, the concentration of reactants and products may or may not be equal. Equilibrium constant K depends on temperature. A catalyst affect equilibrium by increasing rate of both forward and reverse reaction. For an exothermic reaction, increase in temperature decreases the value of K. For an endothermic reaction, increasing temperature increases K. Le Chatelier's principle predicts direction of shift when conditions change. Removing a product from an equilibrium mixture will shift equilibrium to right. Adding more reactant shift equilibrium to right. When pressure is increased, equilibrium shifts toward the side with fewer moles. Equilibrium constant K for a reaction is expressed in terms of concentration or pressure. A large K value indicates more products. For heterogeneous equilibrium, pure solids and liquids are excluded from K. If value of Q is greater than K, the reaction proceeds forward. If value of Q is greater than K, the reaction proceeds reverse. At equilibrium, Gibbs free energy change is 0. Delta G naught is related to K by delta G naught equal to minus RT ln K. If delta G naught is less than 0, then K is greater than 1. In the Haber's process, increasing pressure vapors of formation of ammonia because fewer moles of product size. Increasing temperature in the Haber's process exothermic reaction decreases the yield. The effect of pressure change applies to gaseous equilibria. The equilibrium is established when rate of forward reaction equal to rate of backward reaction. If a reaction Basel expands, equilibrium shifts toward more moles. Adding a catalyst changes reaction mechanism. For A to B is the reversible reaction, K equal to 1 means both favored equally. Units of Kc depends on reaction stoichiometry. Kp equal to Kc RT delta N is derived from ideal gas law. Delta N in Kp Kc relation refers to change in moles of gas. When delta N equals 0, Kp equals to Kc. In an exothermic reaction, equilibrium constant decreases with increasing temperature. In an exothermic reaction, equilibrium constant decreases with increasing temperature. Van 't Hoff equation relates K with the temperature. The equilibrium direction upon heating an endothermic reaction, right? At equilibrium, macroscopic properties are constant. A reversible reaction is one that occurs in both directions. The equilibrium constant expression excludes aqueous and gaseous species. The reaction constant helps to predict reaction direction. For a reaction with very small k, the reaction is reactant favored. Le-Chatelier's principle applies to concentration, pressure, temperature. Decreasing volume shifts equilibrium towards fewer moles. The equilibrium constant for reverse reaction is reciprocal of forward. The equilibrium constant for reverse reaction is reciprocal of forward. For a reaction A to B, Kc has units liter per mole. If Kp equal to Kc, then delta N equal to 0. Adding inert gas at constant volume does not shift equilibrium. For reaction with delta G not equal to 0, K equal to 1. At equilibrium, the rate constant ratio is Kf over Kr equal to K. Adding inert gas at constant pressure shifts toward more moles. At equilibrium, which is true, rates are equal is the true. Equilibrium constants is dimensionless or when using fugacities. For gaseous reactants, increasing total pressure favors side with fewer moles. For gaseous reactants, increasing total pressure favors side with fewer moles. The equilibrium constant is independent of temperature and reaction pathway, mechanism. So the correct option is D, B, and C. The equilibrium constant is independent of temperature and mechanism. When the delta is enthalpy is positive, increase in temperature shifts right, or catalyst changes activation energy. The law of mass action states equilibrium constant depends on concentration rises to stoichiometric powers. If K is less than 1, then reactant favored. If a reaction vessel expands towards more moles, or decrease in temperature for an exothermic reaction increases K. Reaction is spontaneous when K is greater than 1. Equilibrium constant for solids and liquids counted is 1. When Q equal to K, system is at equilibrium. Ionic equilibrium deals with ionic species in solution. Strong electrolytes completely ionize. Weak electrolytes slightly dissociate. Weierstrahl's dilution law applies to weak electrolytes. Dissociation constant K is used for weak acids. The pH of a solution is defined by as minus log H plus. The pH is equal to minus log OH minus. At 25 degrees Celsius, pH plus pH is 14. Kw at 25 degrees Celsius is 1 into 10 to the power minus 14. A buffer solution resists change in pH. Henderson's-Hasselbalch equation is for weak acid and salt. pH of buffer increases when acid concentration decreases. Common and effect suppress solubility and ionization. Solubility product applies to insoluble salts. When ionic product is greater than ASP, precipitation occurs. pK is equal to minus log K. Higher pK means weaker acid. Strong acid has K very large. Examples of amphiprotic ion bicarbonate. Acid base indicators are weak acid base. Buffer capacity is maximum when pH equal to pK. Amphiprotic species can donate and accept H plus hydride ion. Degree of dissociation increases with decreasing concentration. Ionic product of water increases with increase in temperature. A solution with pH equal to 3 is the acidic. A solution with pH equal to 2 has pH equal to 12. A solubility of silver chloride increases with ammonia. KSP expression for AB2, option B. Increasing pH increases solubility of amphoteric hydroxides. pH of 0.1 molar hydrochloric acid is 1. Basic buffer contain weak base plus salt. Acidic buffers contain weak acid plus salt. Conjugate acid-base pair differs by 1 proton. pH scale was introduced by Sorensen. Strong base includes sodium hydroxide, potassium hydroxide, calcium hydroxide. So all weak base include ammonia, but sodium hydroxide is strong base. Hydrochloric acid is strong acid. Potassium hydroxide is strong base. Ionization of water is endothermic. Acid strength increases as Ka value increases. The ionic product is cation anion. When ionic product is less than ASP solubility product, no precipitation. When ionic product equal to solubility product, KSP saturated. pKw at 50 degrees Celsius is less than 14. Lewis acid accepts electron pair. Lewis base donates electron pair. Ammonia is the Lewis base because it has lone pair. RS acid releases hydride ion. Boron trifluoride is a Lewis acid. RS base releases hydroxides. Bronsted lauric acid is proton donor. Bronsted lauric base is proton acceptor. Example of weak acid, ethanoic acid. Example of strong acid, hydrochloric acid. Example of strong electrolyte, sodium chloride. Example of weak electrolyte, ammonium hydroxide. Salt hydrolysis occurs when the salt comes from strong acid and strong base, weak acid and strong base, a strong acid, strong base, strong acid, weak base. Salt hydrolysis occurs when salts comes from weak acid, strong base, strong acid, weak base. pH of blood is around 7.4. pH of rainwater is usually 5.6. Acid rain is mainly due to sulfur dioxide and nitric oxides. pH meter measures hydride activity. In buffer conjugate base neutralizes added acid or saturated solution contains maximum solute. Supersaturated solution is unstable. Solubility increases with temperature for most solids. Solubility of gases decreases with increasing temperature. Strong acids have K values that are large. Ionic strength increases as concentration increases. Activity coefficient approaches 1 when solution is dilute. pH of neutral solution at 25 degrees Celsius. 7. A basic solution has pH less greater than 7. A solution with pH equal to 1 has S plus equal to 0.1 molarity. A solution with pH equal to 9 hydroxide 10 to the power minus 5. Kb is used for weak base. pH is less than pK, less dissociated. Buffer solution show small pH change. Solubility decreases in presence of common ion. Amphoteric hydroxide dissolving acid in base. Lactic acid is a weak acid. A very small Ksp value indicates insoluble salt. pH equal to 7 at 25 degrees Celsius correspond to neutral. Okay, it's all about some MCQ. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. It's now bye bye. See you again.